Good evening everyone. Today we are going to discuss about the special theory of relativity. So first of all we are going to discuss about the reference frame. Okay? So what is the reference frame? The reference frame is the space used for the mathematical description of physical phenomena and the physical laws that we study. Okay, this reference frame are of two types. So they are of two types, that is inertial and non-inertial frame. So now we'll discuss more about these frames. So the inertial frame is a frame in which the Newton's first law holds. Means the Newton's first law, as you might have studied, that Newton's first law says that every body, means any body, without applying any force on it, it can neither be brought on rest or it can be brought on in motion. That means that when a body, let's take a body is moving, then if a body is moving, then without any external force you cannot stop that body. That body will remain in motion forever. If the friction and other air drag and several other force are not applied, then means if no external force is applied, then a body, if it is at rest, then it will remain at rest, and if it is in motion, then it will remain in motion forever. So this is the inertial frame of reference. And the second is the non-inertial frame. This non-inertial frame is the frame in which the acceleration takes place. This acceleration can be linear or it can be rotational. Okay? Means it can be linear acceleration or it can be the angular acceleration, whatever. Now, let me give you some examples to clarify. So, when imagine that you are traveling in a train. Okay? First of all, the train is at rest on the station. Okay? So, when the train is in the rest, you might feel that everything around you is at rest. No problem. Okay. Now, when the train starts moving, when the train gains some velocity, okay, so then if you look outside of the train, then you'll realize that means you cannot identify that we are moving, means the train is moving, or the outer environment, means the outer things are moving. Okay, means you'll see that the outer everything that you see outside is moving backwards. You will never know that the outer things are moving or we are moving. Means you cannot identify that who is in motion and who is in the rest. Okay? Another example is that when you are traveling in a flight, when you are traveling in an aeroplane, then if you see means actually the train, the aeroplane, it flies over the clouds. So when you see outside, you'll not recognize. You'll find that we are at rest. And if you see the ground, means the earth, then you'll realize that the ground, the everything that you see in the ground, means actually you'll see tiny dots, just like a tiny dots on the earth. You'll realize that they are moving, means you'll think that they are moving. Okay? the life carries on inside the plane exactly as if it would be it were stationary on the ground. Okay, we say that a plane provides an inertial frame of reference. By this we mean that the Newton's laws of inertia applies, namely when viewed from this reference frame. An object will neither change its speed nor its direction unless acted upon an unbalanced force. This was what we were talking about. The principle of relativity. The principle of relativity refers that. So the principle of relativity says that the basic laws of physics are same in all the inertial frames. Okay? Example, the force, mass, length, time, etc. means they are absolute. They don't change with the change in the inertial frame. Okay? In the end of the 19th century, Mikkelsen and Morley, they performed their famous experiment, which is called Mikkelsen and Morley experiment. And after this experiment, the result that was provided was that the velocity of light in the space remains unchanged. Okay? Later, Albert Einstein gave his special theory of relativity, which solved the reason for the c, that is speed of light, to be constant. He said he gave his experiment and showed that the speed of light is constant. It's constant in any empty space. Okay? He conducted a series of thought experiments that became the basis of his theory. Okay? He also showed the relationship between, means the graph between the electric field and the magnetic field, and he said that magnetic field would change its magnitude with respect to space, not the time. Okay? So there were few postulates also which extended the theory of the special theory of relativity. So the postulate 1, all the laws of physics are held in the inertial frame, means actually we have discussed the inertial frame, that is the, in inertial frame the velocity means is uniform or constant. Okay, so this was the postulate 1, and this extended the theory, the special theory of relativity, like these three equations that are written on the board that you can see. In this, the velocity can vary, but the acceleration has to be constant, means the object should have uniform velocity, or the acceleration should be constant. So this was the first postulate. The second postulate says that light can travel through the space or the vacuum, means the light doesn't need any medium. It doesn't need any medium to travel or to propagate. Okay? This you might have studied that the speed of light in vacuum, it's around 3 into 10 to the power 8 meter per second, and the exact value is 299,792.58 kilometer per second. Okay? This is the speed of light in vacuum. And this postulate, it helped to remove the wrong concept of ether. Actually, earlier, the ether means the concept of ether was given as that the light the light travels in the vacuum through the ether. Means in the vacuum ether is present, which is responsible for helping the light to travel or to propagate. And this is a wrong concept. Today we know that the light can travel through vacuum without any medium. Means it can travel even in the space where there is nothing. Okay? Actually, light travels through the energy particles that are called photons. So the light travels, means it has energy packets that provide it energy so that it can flow even through the vacuum. This is the particle nature, means the particle theory of light that was given by Planck. So, thank you everyone for watching this video.